All right, example 4 is going to be a compound interest problem here. All right, you deposit $4,000 into an account that pays 2.92% annual interest. Find the balance after 1 year if the interest is compounded with the given frequency. So we have quarterly for part A and then quarterly for part B. So basically we're going to use the same equation we're going to build and calculate for both of them. All right, so quarterly, if we look at a little chart here, all right, quarterly is going to be equal to 4. All right, so the year is broken up into 4 parts. That's 3-month intervals. So here we do our calculation, n will equal 4. All right, daily, well, how many days are in a year? It's 365. So n will equal 365. There. So let's go ahead and build this compound. So we have A of t. All right. So it's the amount with respect to time. So over time, that amount changes. We have the principal times 1 plus, a little bit different here, we have a fraction for our rate. So we have the interest rate over the interest rate being divided by the compounds to the power of n times t. So a lot of mistakes happen is that students will forget to put the n on top also. So it goes in both places. All right, so don't forget to do that. 1 in the denominator and 1 up in the power. Okay, so let's do part A. So we're going to take our A of t here. Equals our principal is $4,000. All right, we have 1 plus, and then we got our fraction here. Converted to a decimal, it's going to be 0.0292. All right, so that's what we're going to put in there. All right, all over our compound. In this case, this one's going to be 4. So the power 4 for the compound again. I like to write it right away just so I don't forget. And then we're going to multiply it by our t, so times how long were we putting this for after 1 year, so it's just going to be 1. All right, so the year isn't going to affect it too much. All right, let's go to our calculator. Got our decimals here. Okay, so hit enter for a new calculator. So we need 4,000. All right, so pay attention how I do this so that you can get your calculators do it right in decimals here. So we're going to have 1 plus. Then I'm going to put another parentheses for the fraction part. So I got 0.0292. Okay, then I'm going to click the divided sign, and it's going to make it a fraction for us already. And then the denominator is a 4. Okay. Then arrow to the right, close the parentheses, close it again. So we have 2 complete sets there. Hit the power key. And then we're going to put 4 times 1. You don't really need the times 1, but it's there. Now look what I did there. See how that 1 comes down? It's out of the power. That'll mess up the calculation if it was another number other than 1. So to do that in your power, if you do have a different number other than 1, you're going to need to put another parentheses. So 4 times 1. That way it knows to keep everything up in the power. So in this example, we're just dealing with 1, which doesn't really affect anything. But if you had like over 5 years, then yeah, that'll drastically mess up your calculation. So be very careful if you're multiplying there, or either multiply it on your phone and then put that number in there. So if it's like 4 times 5, it's 20. You can just put a 20 up there. But if you want to just put it in all in decimals and then hit one button, there it is. All right, so we get $4,118 and basically 9 cents. I'm going to round to the penny. We're dealing with money. All right, so let's write this out. Dollar sign. 4,118 and 9 cents. All right, and there's the answer to part A. Now part B will be very similar. Okay, so we're going to have 4,000 times 1 plus 0.0292 over 365. This is a great example because we're going to see how compound interest changes the initial amount. So times 1, and being after 1 year, we can see a really good comparison. Okay, so let's put this in our calculator. All right, and basically what I could do is I could just, instead of having to type everything in back in, I could change where the 4 is. Delete the 4, I'm going to put 365, and all I'm going to do is just change where the compound part is. So kind of a shortcut. All right, and then we get 4,118 still dollars still, but this time we have 52 cents. Okay, again rounded to the penny. So 4,000 $118.52. All right, so a little bit different, but not much. But if you look at the two compounds, the more times it's compounded, the more money you're going to make. Or if this is debt, more money is going to be charged to you. So the compound doesn't really mess with your equations too much. So if you are looking to invest, the biggest things you want to look at is the initial amount you get to put in there. So obviously, the more money you put in the bank to start with, the more money it'll make and grow faster. But where the power is how long you leave it in there. So if you put it in there more than 1 year, that's going to make your amount grow bigger. So bigger principal, longer time. That's why they say youth is on your side. And then, of course, interest rate. Interest rate will affect it much more than compound. So if you don't know the exact compound, whether you're doing taking a loan or investing, you can pretty much just guess using 12. I would recommend 12 because most things are done compounded monthly. So, and if it isn't, as you can see, we're talking about like pennies pretty much here. Not too much of a difference after a year.